Hello everyone, welcome to the Learning Cubicle. Now let us get back to the example of you going to your friend's house. In the morning, when you found that the gates were closed, you opted this path. But it so happened in the morning that you found your friend's house was locked. Okay? Now, since your friend's house was locked, you continued to go in the same path and then you came back to your house. Right? So, you tried your luck in the evening, you went to your friend's house in this path, and since it was your birthday, so you went and gave some sweets to your friend and his parents, and then you came back. Okay? So, in both of the cases, you started from this point and you came back to this point, which is your house. Either this road or this path. In both the cases, you started from one point and returned to the same point. Now, if you add these all these lengths from here to here, then this, then this, then this, and again this. If you add all these lengths of the path that you have covered, that will give you distance. Because we discussed that distance is the total length of the path covered by a body during its course of motion. Now, let us see what about displacement. You started from here, you went like this and came back here. So, your initial point of journey and the final point of your journey are same. So, when the initial point of your journey is this and the final point of your journey is also this, then the displacement would be 0. Now, why is it 0? Because according to the definition of displacement, it is the shortest distance between the initial and final points and also in a particular direction. In this case, we do not have two different points, initial and final points. They are one and the same. That's your house. So, you started from that point, you went around and came back in the morning, and in the evening you just went along that path and came back. So, in both the cases, the initial point and the final point are same. So, we cannot measure any distance because the point is only one. So, the shortest distance between the initial and final point in a particular direction doesn't apply in this case. So, when a body starts from one point and returns to the same point, in that case, the displacement is 0. The best example of this would be you going to the school in the morning and returning to your home in the evening or in the afternoon, which is the case of displacement is 0. Alright? So, if we take any case, it can be any path. Suppose a body has started over here, then it has gone in this path, some path like that, and finally it is coming here, coming back to the same point where it started, then the displacement would be 0. Whereas the distance would be the length of this weird diagram that I have drawn over here. So, distance is the total length of this path, whereas displacement is always 0 because there is only one point. The initial and final points are 0. Sorry, our initial and final points are the same. My mistake. Right? So, displacement of a body which starts at one point and returns to the same point is always 0. Now, if you observe carefully, when I talked about distance, I was telling you that it is the length of the path covered by a body from the initial point to the final point. Whereas, when I talked about displacement, I said that it is the shortest distance between the initial and final points and also in a particular direction. So, when I was talking about distance, I was only talking about the length. Whereas when I was talking about displacement, I was talking about the length and also the direction. So, the quantities which are expressed only in magnitude, magnitude means some numerical value, 7 kilometers, there 7 is the magnitude, 20 degrees Celsius, their magnitude is 20, okay, and 40 Newton, 40 is the magnitude. So, the quantities that are expressed only in magnitude like distance are called as scalar quantities. Quantities which are expressed only in magnitude are called scalar quantities. For example, distance. I didn't talk anything about direction when I was talking about distance. Temperature is another thing. Okay? And energy, heat energy, sound energy, energy is also an example of a scalar quantity. So, the quantities which are expressed only in magnitude are called scalar quantities. Whereas, the quantities that are expressed in both magnitude and direction are called as vector quantities. The quantities that are expressed in both magnitude and direction are called vector quantities. Example, displacement. I told you. So, whenever we say the displacement of a body, we associate direction to it. 50 meters towards right, 70 meters towards north, 10 kilometers towards east. So, we associate direction whenever we talk about displacement, which is a vector quantity. So, there are some more examples of vector quantities like force. Force is an example of a vector quantity. 10 Newton force in the upward direction. 40 Newton force towards northeast. So, we associate direction to certain quantities. So, such quantities are called vector quantities. It may be force or weight or displacement, and some other quantities we will be learning in this chapter which are also vector quantities. So, vector quantities are those quantities which are expressed in magnitude as well as direction. Okay? So, displacement is a vector quantity, whereas distance is a scalar quantity. Distance is only the length of the path covered by a body from its initial point to the final point during its course of motion, whereas displacement is the shortest distance covered between the initial and final points and in a particular direction. Distance can never be 0, whereas displacement can be 0 if a body starts from one point and returns to the same point. Clear? And distance is always greater than or equal to displacement. It can never be lesser than displacement because displacement is the shortest. Distance is always greater than or equal to displacement, whereas displacement is always lesser than or equal to distance. Okay? So, from this statement you should understand that there can be a case where distance and displacement are equal. Now, when is that? When is that going to happen? When will distance and displacement be equal? Let us see an example for that also. Okay? Now, Let us suppose that there are 2 points. There is a point A over here and there is a point B over here. Okay. Let us suppose that a body has moved from this point to this point in this manner. Okay. Now the distance is nothing but the length of this line segment. The length of this line segment is distance. At the same time, the shortest distance between this point and this point is also the same, and it is happening in only one direction. So this is also displacement. This is also displacement. So when a body is moving from one point to another in a straight line, then the distance and the displacement are equal. When a body is moving from one point to another in a straight line, then the distance of the body and the displacement of the body are equal, which is nothing but the length of the line segment that you have drawn, joining those 2 points. Let us suppose the body moves from A to B in this manner. Let us suppose the body has moved from this point to this point in this manner. So the total length of this curvy line becomes the distance, whereas the length of this line segment, straight line segment that we have drawn between A and B becomes the distance, displacement. Please get it right, because displacement is the shortest distance. So shortest distance will always be the straight line, and distance is the actual path covered by the body from the initial point to the final point. Am I clear with that? Okay. So that is about distance and displacement. We will learn about some other topics in this lesson in the next class. Thank you.